Hi everyone, I'm Murat, Cakmak, the founder of ZAYA. We are developing software solutions for RISC-V. Actually, RISC-V has very rich software environment, software ecosystem. But today we're gonna talk about the security and maybe some rich programming models for RISC-V. Actually, the rich models is also part of the security. But first of all, the title is Certified Security for Containerisation, but for microcontrollers. Because, you know, the rich operating system environments like Linux, whatever, they are quite mature, they provide some security features, isolations, but we are trying to protect even microcontrollers, maybe don't have any built-in hardware security features. So actually it's a generic problem, but let's talk about RISC-V. So if you are developing a product, there are some challenges. For example, security is one of the most critical things because now we are developing connected devices and we are opening our devices to the whole around the world. So we have to protect it. But also the other problem is, actually not problem, certification and any compliance. Because in the US, in the EU or UK, in Far East, Singapore, China, there are legislations they are approaching and your products must be compliant with all of this legislation. Also legislations map some certification, security certification. So we need to consider during the development. Also, the other thing could be modularity. You know, in the microcontroller world, the solution is quite primitive. So maybe single executable, they include everything and everything has access for everywhere. So it's like single bunch of everything. But modularity could help us even in the microcontroller world to build maybe secure, compliant or certification friendly environments. And of course functionality. There are nice functions for the PCs, servers, but we don't have for the microcontroller levels. So if we had, we could provide richer, better products, RISC-V products. At the moment, probably you have lots of products around, like partial solutions. They solve a partial problem, but we need a complete solution for RISC-V. Also, it is critical for security, and security needs individually secure modules, maybe guaranteed, maybe certified, maybe tested well, maybe tested by a third-party authority like security labs. Also, secure integration. The integration must be secure. Also, the interaction between the module, and it must be done for whole edge to cloud. Otherwise, any weakest link can leave a problem or can leave a backdoor for the attackers. So after this small introduction, let's build together how can we create a secure and rich system. So maybe, sorry, there are lots of text here, but let's have a look at. First of all, okay, if you are trying to create a security solution, first we have to protect security solution itself before protecting the whole product. So we need to create an isolated space for the secure or critical operations. So we can call like a trusted execution environment or security monitor. And I would say there could be two different requirements for it. For example, it must be design time independent. So herein I mean the independent executables. For example, if you have a security solution, security, it must be independent from. It should be. Let me say should be. It should be independent from the user space application, because when you update an application or user space execution, it shouldn't affect the TE or RISC-V. For example, it shouldn't affect its signature because maybe you are certified your TE and certified by security lab, and you shouldn't modify it. At least you need to guarantee it you don't modify your TE for user space modifications. And you know, in the classical solutions for the microcontrollers, like classical RTOSes, there is just one image including everything, like kernel, drivers, middlewares, user applications, mixing of all of them. So even 1 byte in application, it affects the whole image, or also a signature of the image. And if we could have an independent solution, we could have an individually certifiable module. So you can have even third-party certifiable as an independent executable, and it wouldn't affect the rest of the system. Also, individual deployments. For example, if you are just updating a user application, why do you need to update your TE or security? So it must be independent executable to deploy independently. And of course, for the second one, it must be runtime isolated. So in the runtime, the user space shouldn't modify the security monitor or TE. And TE should handle all security requirements for you. Then in user space, you could be security free and you don't need to think about security or certification. Then you can just focus on user space, end user application. And for example, it can be PSA tangles or CSIP, or can be requirements from ETSI, NIST, whatever. And it should be, and maybe it must be assessed by a third party, like security lab, and it should be certified. I mean, the TE should be certified. And as a conclusion, it should make the user space security and certification free. So after these requirements, let me tell what we are providing for RISC-V as a minimal configuration. Sorry about the logo, I don't know why it looks like this. So, ZAYA for the RISC-V, even for MMU-less, very small microcontrollers, creates an isolated space like a TE or root of trust or security monitor, whatever you call. And it handles all security requirements in this space. For example, the security requirements from PSA, like it should handle security lifecycle, secure boot, secure update, anti-rollback protection, whatever. And ZAYA also provides a standard API for crypto, because you know there are lots of APIs for like Embed TLS API, Wolf SSL, OpenSSL, whatever. All they are different, but PSA provides a standard API, and ZAYA exposes this functionality using the standard PSA API for the user space. And it is isolated. And for the user space, you can have rich OS environments like multiple execution services. I will detail. And it is security free, and it is also certification free for the essential certifications, let me say. So both they are different independent executables and runtime isolated. And let me say, this solution is a PSA certified solution. PSA certified, it meets all requirements, and PSA API certified. ZAYA is the world's first PSA certified operating system in 2019, 4 years ago. And now we have the world, one of the first RISC-V PSA certified on RISC-V core. It's for Bilaytek Limited, and it used a ZAYA secure kernel to meet requirements. Of course, we use some security from like hardware crypto acceleration from Bilaytek, but for the missing requirements, ZAYA fulfill, and it makes the whole device as a certified. Okay, now we have a secure TE security monitor for the RISC-V, so it's great, but it is not enough. So maybe we can provide more rich programming model for the user space, more security, more functionality. So let's define what could we have for the user space more in addition to the TE. So first, if we could provide modularity, or probably I will not able to pronounce this, but compartmentalization for the user space. And we could divide executions into submodules, like microservices, maybe user application, maybe untrusted things. And it can be design time independent, like TE. It can be independent executable, even for microcontrollers. So while you are using one tool chain with one of them, you can use another tool chain. And all these can be developed by the different teams, maybe. And it must be, of course, runtime isolated. Process isolation we call in operating system theory. And independent deployment, as I mentioned in the classical RTOSes, you cannot deploy independently. You have to deploy all of the codes. And it must provide individual certifications. Then we could provide a platform agnostic portable approach. So you should be able to easily port a module to another architecture or hardware easily, and it must be rich and of course secure. So you can see the whole picture like what we are offering for the RISC-V, even for MMU-less microcontrollers. So you are already familiar with this one. It is responsible for security. I'm going to explain this part later. And for the user space, you can have different containers, and we call them ZAYA microcontainers. It comes from microcontrollers, containers for microcontrollers. So you can have ZAYA provides ZAYA TE, RISC-V TE provides containerization, and each containers are independent executables. They are not linked to each other. You can deploy independently all of them. And you can use for different purposes. For example, you can just run your cloud services as a background service. It can be interpreter like Python, Rust, or it can be even virtual machine. For example, if you like your RTOS, and if you don't want to leave it, you still run a guest RTOS inside a virtual machine, and you can make use of security from the ZAYA, and it is isolated and it cannot violate the rest of the system. Or you can just isolate it to untrusted third-party library in a container. Then you can start user app developments. So this is we can say this is user space, this is kernel space. But if you have RISC-V supervisor boot, you can have if you call it PSA platform root of trust, you can have PSA application root of trust for custom security extensions or certified third-party stacks. For example, for payment systems, EMV stacks, as an example. Actually, we protect whole device using the PSA security requirements, but we also protect microcontainers using the PSA requirements. So it is more than classical containers. They are secure containers. You can have brochures, so you can have these details in the brochures. But in addition to PSA requirements, we also offer access policy for containers. It's a logical solution, so you don't need to be a security expert or RISC-V expert. So you can define your resources. You can give privileges for different privileges for resources, and you have to explicitly assign a resource to container. By default, a container cannot access any resource, so you have to explicitly assign, but it is not enough. Also, the container privilege level must be enough to access a resource privilege level. So it is a logical definition to simplify the security for a microcontainer. These are the use cases. Actually, I already mentioned some of them. Actually, in addition to, you can create your microcontainers, microservices, but we also provide plug and play turnkey microcontainers like microservice in binary format. Just download and have the capability. But you can have details in the brochures, probably more. And that's all. Thank you, guys.